In section 7.3, we're going to talk about solving both equations and inequalities that contain radicals. And the basic technique is you want to isolate or get by itself the radical on one side of your equation. If there happen to be two radicals, separate them, get them on opposite sides, and then apply an inverse operation. The inverse of a square root would be squaring, the inverse of a cubed root would be cubing, and so on. One quick note here. It's important to check all of your solutions. Sometimes we get what's called an extraneous solution. It means we haven't done anything wrong algebraically. We just get a solution that doesn't turn out to actually work. And that happens sometimes, particularly with even roots, square roots, fourth roots, and so on. So let's try this. In example 1a, we already have a square root that's been isolated. It's by itself. And so I'm just going to start by squaring both sides. Following our old rule, kind of do what you want in an equation as long as you do it to both sides, right? All right. Squaring and the square root are inverses. They do and undo. So I just end up with x minus 3 over here on the left, and 5 squared, or 25. That's going to give me x equals 28. And before I actually say, yes, I'm done, that's true, I'm just going to double check. If I plug in 28 for x, I do indeed get 5 for an answer. And that solution is perfectly good. All right, in B, I have the cube root of x plus 2 equals 5. I want to start by getting the cube root by itself, so subtract 2 from both sides. Right. By the way, notice over here, the 3 was under the radical, so I couldn't add it to the other side. Here the 2 is not under the radical, so it's okay to subtract it. All right, so I've got the cube root of x equals 3. I'm ready for my inverse function. To get rid of a cubed root, I use a third power. If I do something on one side, I must also do it on the other. And there I've got my inverse functions happening again. So all that's left this time is just x. And over here, 3 cubed would be 27. If I want to double check that, the cube root of, and I'm going to put in 27 for x, add 2 is 5, which is exactly what I expected. So my answer checks out. All right, C. I've got a square root of x plus 1 as my radical in this problem, and I'd like to get that by itself before I do anything else. So I'm going to add the 4. And that gives me 15. And I can divide by the 3 without it making it come out to be a fraction. Don't love fractions in these situations, so sometimes I don't do the dividing step. But in this case, it comes out evenly, so I'm going to. All right, square roots by itself. I know the inverse function would be the squaring function, so let's square both sides. Those inverse functions work. And I have x plus 1 equals 9. And so x equals 8. All right, let's try it out. 5 times the square root of 8 plus 1 get out of the radical, minus 4. I'm sorry, you didn't see any of that. Let me do that again. 5 times the square root of 8 plus 1. Then I got out of the radical to put the minus 4. And notice that I did get the 11 that I was expecting. So that seems to work as well. All right, what about D? To get this radical, that fourth root by itself, I would subtract 8. I had a 3's on this page. I must have been in a 3 mood when I wrote these problems. All right, I want to get rid of the fourth root. The inverse function would be the fourth power. And again, I let my inverse functions get rid of each other. That gives me 3x minus 1 equals negative 3 to the fourth. Either you know or you can do it on technology, should give you 81. So 3x equals 82. And if I divide by 3, that's not going to come out evenly. So I'm just going to give the exact answer as the fraction 82 thirds. Oops. And I went ahead and said that was true, but I better double check it to make sure. Bet I might be in trouble with this one. Let's see. All right, I got 8 plus the fourth root of 3 times my x, which is 82 thirds, minus 1. It's supposed to be 5, but it's not. It actually gave me 11. So, even though I don't think we did anything wrong here, the answer I got didn't work. It's what we call an extraneous solution. And in fact, there is no solution to this equation. To be honest, I could have predicted that early on. Let me show you. Just like square roots, that symbol, that square root symbol, is always considered to be positive. Same thing happens with any other even root, a fourth root or a sixth root. We have an agreement that that symbol means the positive result. So actually, as soon as I saw that turn out negative, I knew my answer wasn't going to check. But I wanted to make sure to go through and show you the whole process. All right. What about E? This time I've got 2 radicals in the problem. I obviously can't get both of them entirely by themselves, but I can at least separate them. So I'm going to go ahead and take this one that's negative and I'm going to add it to move it to the other side. All right, to get rid of the square root, I need to square both sides. And notice this square has to apply to both factors. So 3 squared is going to be 9. And then when I square the square root, those are inverse functions. So it just gives me x minus 4. But be very careful here. Just like the 3 multiplied the whole radical, this 9 has to multiply the entire x minus 4. Those parentheses are essential. All right, equals. On the other side, I've just got squaring a square root. So 3x plus 5. All right, nice linear equation here. That's 9x minus 36 equals 3x plus 5. I am going to subtract the 3x and add the 36. So I have 6x equals 41. And just dividing by 6, again, that's not going to come out evenly. So I'm just going to leave my answer as the fraction 41/6. All right, maybe I better not be in such a hurry to circle it. Let's see if it actually worked. 3 times the square root of x is 41/6 minus 4. Outside of the radical, subtract, and then a new radical. 3 times my number, 41/6 plus 5. And I do get 0, exactly what I was expecting, so this time my answer worked just fine. All right, one more equation to practice with here. This one only has one square root in it, so I'd like to get that square root by itself, meaning I'm going to take that plus 1 and subtract it to move it to the other side. All right, got to get rid of the square root, which means I want to square both sides. Squaring is my inverse function. And squaring the square root just leaves me 2x plus 5. Remember to be really careful when you square a binomial, right? You want to write it out, 2x minus 1 times 2x minus 1, so that you don't accidentally make a mistake and forget the middle term. All right, let's see, that's 4x squared minus 2x, another minus 2x, and then plus 1. So that's 4x squared minus 4x plus 1. And this time it's quadratic. So with quadratics, we want to get 0 on one side. So I'm going to subtract the 2x and also subtract the 5. That gives me my 0 over here on the left. And that would equal 4x squared minus 6x minus 4. All right, I know I could factor a 2 out of there. And if you want to, you can just divide the 2 out. And then I'd like to see if I could factor that anymore. Let's see, I would need a sum of negative 3 and a product of negative 4. So how about positive 4 or positive 1 rather, and negative 4. So I have 2x squared plus 1x minus 4x minus 2. Which is x times 2x plus 1 minus 2 times 2x plus 1. And so that factors us 2x plus 1 times x minus 2. All right, so either 2x plus 1 equals 0 or x minus 2 equals 0. This one would say 2x equals negative 1. So x is negative 1/2. And that one just says x equals 2. So I have two potential solutions, right? I need to check them both and see if either one or maybe both of them actually work back in my original equation. I'm going to try the negative 1/2 first. So if I have the square root of 2 times negative 1/2 plus 5, and then add 1, that's supposed to equal 2 times negative 1/2. And of course, those are not equal. So this guy was an extraneous solution. Doesn't work. Let's try the 2. Let's try the other possible solution. Square root of 2 times 2 plus 5. Get out of the radical. Plus 1 is 4. And the other side, 2 times 2, of course, is also 4. So that one seems to actually work. And I got one of my 2 solutions that worked out. All right, that one was about as complicated as I would expect you to be able to solve by hand. Anything more complex, like the examples here in example 2, I'm going to say we're going to go ahead and solve using technology. It's not that, especially this one's not solvable by hand. Actually, they both technically are, but they're just beyond the scope of what I expect you to do in this class. So let's go ahead and graph this or solve this using graphing methods. Again, my personal preference is I like to get them equal to 0 so that I can just get the x-intercepts. So on this one, maybe I subtract the square root of x. So that I've got the 0 over here on the left. By the way, a quick reminder, you can't combine those, right? They're not like radicals. So I'm going to go ahead and graph that function and see where it's 0. See where the zeros or x-intercepts are. So it was the square root of 3x, subtract 2, subtract the square root of x, and I definitely see an x-intercept or a 0 right there at about 7.464. It doesn't seem like that's going to come back down. If I go out here, it's not looking like it, so I think that's probably the only solution. So I'm going to go with x is approximately 7.464. All right. The second one, again, I'd like to get it to equal 0. It doesn't really matter. I'm going to go ahead and move things to the left this time. I have the x minus 2 squared. I'm going to subtract the square root of x plus 3 and subtract the 2. By the way, I didn't mention this earlier, but it probably is worth mentioning. Notice when you subtract a square root, the sign under the radical doesn't change. It's just the sign in front of it, right? All right, I want to know where that's equal to 0. So once again, I'm going to graph. X minus 2 squared, subtract the square root of x plus 3, subtract 2. This time, I see 2 solutions. It looks like x is approximately 0.063, and x is approximately 4.162. By the way, you don't have to worry about extraneous solutions when you're using solutions from a graph. Extraneous solutions don't show up on a graph. So if you find 2 solutions, they're both 2 true solutions. So there's those. All right, we're going to wrap up this section by talking about some inequalities. Once again, I don't think you're going to find any technique particularly new here. We'll solve inequalities pretty much like we've always solved inequalities in this class. We will make a related equation, which we'll solve, And then we'll use that solution or those solutions to break our number line up into intervals and test a point in each interval. So let's start with our related equation here on this first one. It would be 9 minus the square root of x squared plus 4 equals 3. If I want to get the square root by itself, I could subtract 9. And I can even divide both sides by -1, which would make this one positive. It would make that a positive 6 as well. All right, let's square both sides. Which gives me, let's see, inverse functions here, x squared plus 4 equals 36. So x squared would be 32. And if I take the square root of both sides, I get x is plus or minus the square root of 32. Let's see, let's try breaking that down. Square root of 32, I could break that down as 16 times 2. So plus or minus 4 times the square root of 2. Now I'm going to put that on a number line. It might be helpful to have some decimal approximations. So 4 times the square root of 2 is about 5.66. So about plus or minus 5.66. All right, I'm going to use those to create my number line to do my test. And I need to pick some test points, one for each interval. So I'm going to go with -7, 0, and +7 this time. And remember, what I'm actually trying to test is that. So I'm going to go ahead and go over into Desmos. I'm going to put this into my Desmos. I'm going to put that in as my function, and I'll plug each of my test values in and see if they're really less than 3. All right, so for my f of x, I'm going to go with 9 minus the square root of x squared plus 4. And I'll make a little table for each x, each test value. I want to find f of x1. And the first test value I chose was -7. Gives me about 1.72. And remember, I wanted that to be less than 3. That is true. The next test value we chose was 0. Gives me an output of 7. Again, I want that to be less than 3, but since it's not, that interval will be false. And then my last test value was +7. That gives me the 1.72 again, which is less than 3, meaning the last interval will be true again. So there's my by hand work, just documenting the inequalities from what Desmos gave me, and it turned out true, false, true. So let's see, this was strictly less than, so all parentheses. From -∞, and if I want to, I could go back and write that as -4 square root 2, so I have it exact. and then from positive 4 square root 2 to infinity. All right, let's do one more. There is a typo here. Sorry about that. That was an equation, not an inequality. So if you'd please change that and make that the cube root of x greater than or equal to 2x, if you still have a version with the typo on it. All right, this one's got x's on both sides, so I didn't bother to get the 0 last time, although I could have, but I think I'm going to go ahead and get the 0 this time. The cube root of x minus 2x is greater than or equal to 0. That's what I'm trying to solve. All right, let me write down my related equation. The cube root of x minus 2x equals 0. And I'm actually going to move that 2x back over to isolate the radical before I do my inverse function, which would be the inverse of the cube root, would be the third power. Those inverses leave me just x on the left-hand side. And on the right, don't forget to apply that third power to both of the factors. 2 cubed would be 8, and then x cubed. All right, let's see. To solve this polynomial equation, I want to get that equal to 0, so I'm going to subtract the x. I can factor out an x. Leaves me 8x squared minus 1. So I get x equals 0, or I get 8x squared minus 1 equals 0. This one would say 8x squared equals 1. So x squared is 1/8. And just a reminder, I had x equals 0. And now I'm going to have x, if I put my square root on both sides, would be plus or minus the square root of 1/8. I want to simplify that. Let's see, the square root of 1 on top. The square root of 8, I can split that up as square root 4 square root 2. So maybe plus or minus 1 over 2 square root 2. I can also get a decimal approximation for that. It might be easier to just do the square root of 1/8 if I'm doing it in my calculator. About 0.35, plus or minus. All right, so 3 points to put on my number line to test. And again, just a reminder, this is what I'm testing. I got negative 0.35, 0, and positive 0.35. All right, so for test values, I'm going to go with negative 1, negative 0.1, positive 0.1, and positive 1. And I put that function into Desmos, and then I'll test all those little test values that we just picked. By the way, if you search a bit, you probably can find a cubed root on Desmos, but I'm going to remind you, the cube root of x is really just x to the 1/3 power, right? So a lot of times, rather than going and searching for the cube root somewhere, it's faster for me to just type it as the fractional exponent. All right, subtract 2x. And I'll make my table. For each x1, each test value, I want to plug in to that function, f of x1. And my first test value was -1. That gave me 1. And I wanted this to be greater than or equal to 0, which it is. So that's true. My next test value is -0.1. That gave me -0.26. Would like that to be greater than or equal to 0, but it is not. So false in that section. Then I have +0.1. That gives me +0.26, which is greater than or equal to 0. So now I've got a true. And my last test value is 1. Gives me -1, which is not greater than or equal to 0. So last section is going to be false. And there's my table based on those values that Desmos gave me. All right, my true section runs from -∞ to -0.35, or I could write it as -1/2 square root 2. And let's see, that was greater than or equal, so I can use a bracket there. And then again from 0 to +0.35, which is +1/2 square root 2. All right, so there are inequalities solved with the same basic system as what we've seen before. And that brings us to the end of 7.3.